Okay, welcome to video 1.13. We'll be discussing pages 25 to 31. And then once you have finished doing the work in the workbook up to page 31, that will be the end of chapter 1.1. And then you can come and see me, and when you're ready you can write the quiz. Okay, but only make sure that you understand the material thoroughly up to page 31 before you come and see me to write the quiz, because you want to pass it on the first time. That's the whole goal, is that you take your time, you understand the material, do the work in the workbook, every question, make sure you've checked the answers from the answer key solution manual. I've got the binders at the front of the room, or you can find the solution manual online, and you have a link to that. And then you're ready to go. Okay, so 1.13, we're going to be talking about identifying what we call non-linear relations. Now, we already know that a linear relation, let's stop that right now. A linear relation, there's my x, there's my y-axis, deals with straight lines, okay? A nice straight line. That's called a linear relation. But what happens if we have a situation where we have a line, but it's nonlinear? A nonlinear relation. Well, what does that look like? Well, it can be pretty much any shape other than a straight line. So, for example, it could be a curve like this. It could be a curve like that. It could be a parabola shape like that. These are examples of nonlinear relations. Well, what does that look like in terms of a table of values? Well, we know in a linear relation, if we have a table of values with corresponding data points, okay, we can call this maybe x and y. And let's draw a few columns in here and rows. Suppose we have 0 and 5, 1 and 10, 2, 20, 3. Now these are just numbers, no units to them at all. It's just an example. 4 and 40. We can tell from a table of values whether we have a linear relation or a nonlinear relation just by the difference between the values of x and difference between the values of y, because these all go up at a constant rate of 1, and these, let's make that 0. These all go up at a constant rate of 10. So we have a constant rate on this side, the x, and we have a constant rate on y, then we're going to end up with a straight line. In a nonlinear relation, if we were to have a table of values, like this, and I have an x and a y, and let's say I have 0, 2, 4, 6, and 8. Notice how these all go up at a constant rate of 2. But over here on the y, let's say I had 5, 15, 40, 70, and maybe 100. From here to here is 10. From here to here is 25. From here to here is 30. And from here to here is also 30. Notice how these do not increase at a constant rate. For it to be a direct linear, or not a direct relation, a linear relation, both values x and y must go up at a constant rate. over here, we've got our x values going up at a constant rate, but we have our y values going up at a non-constant rate. So if I was to graph something like this, there's my y, and there's my x, there's my origin, 0, 0, and I was to label this x, well, let's just say that this is 2, 4, 6, 8, and over here my highest number is 100, so I want to make sure I'm at 100 at the top, and maybe this is 75, and this is 50, and this is 25. I go to my first coordinate, which is 0 and 5, so x is 0, and it's going to start right there at 5. So already I know that if I wanted to find out if this was a partial or direct linear relation, and I know that it doesn't start at 0, 0 at the origin, it starts at 0 and 5, so I know that's a partial linear relation. And then I go to 2 and 15, so 2 and 15 is about maybe right there. And 4 and 40, so 4 and 40 is up here. 6 and 70, 6 and 70 is up here, and 8 and 100 is up here. So you can see it kind of goes at a slight curvature like that. This is not a straight line. This is what we call a non-linear relation. So this table of values, table of data, basically describes a non-linear relation. So if we wanted to, let's say, calculate the slope of a nonlinear relation, we really couldn't do it because we know that the slope can only be for a straight line. But what we can do is we can calculate the slope in between 2 points. I could calculate the slope between this point here and this point here. I could calculate the slope between this point here and this point here, here and here, and here and here. Now, if it is a linear relation, the slopes will all be the same. They have to be because it's a straight line. Because over here the slope is 10 between each point. 10, 10, 10, and 10. 10 divided by 1 is 10. Here 10 divided by 1 is 10. Okay. 40 divided by 4, 30 divided by 3, 20 divided by 2, 10 divided by 1. Okay, the slope is all 10. Over here, if I want to calculate the slope, I have to go between this point and this point. It's going to have a value. Between here and here, it's going to have a value. And I already know that the slope is not going to be the same, because if I was to take the slope between this point and this point, and this point and this point will be different between this point and that point, because we know it goes at a curve. So to be a linear relation, the slope must be the same between the points. Now if you take any 2 points, calculate the slope, and then take another 2 points, calculate the slope, and they are different, then we know that it is a nonlinear relation. It is basically a shape, maybe a curve, and not a straight line. Okay, so simple concept. Go through your workbook, do up to page 31. There's 3 or 4 examples of drawing graphs from a table and understanding nonlinear relations. And then when you've completed this, you've completed section 1.1, and you're ready to write the quiz. All right?